Welcome to week 9, Air Pollution and Control, NPTEL live session. I am Abhishek Raj, a PMRF scholar from IIT Madras. Coming to the overview. We'll start with overview for week 9. Practice assignment we'll have around, I think, 18 questions this time. Uh, Maybe next week, I think, week 10, if you have seen the lectures, there will be some numericals. So next week we will do less questions, maybe around 15 questions only we will do because we'll have numericals, so it will take time. This week we'll stay with the usual number, 18 to 20. Then we can take the doubts. So starting with the overview. So lecture 1 was about the air pollution control. So till now we were seeing how the air pollution works, what are the models for dispersion, how it is monitored and those things. Now we'll see like how it can be controlled, what are the devices that are being used in research as well as practice to control air pollution or minimize it. So the control can be at two levels. So first one we can have stationary control and then we can have in mobile sources like automobiles. So stationary control can be, let's say, in industry, and mobile sources can be for automobiles. Coming to lecture 2, it was about the removal mechanisms. So different mechanisms exist for different types of conditions. So we had discussion on settling chambers and separators. Lecture 3, so carrying over from lecture 2, so fabric filters are used. So basically they are cloth-based filters which are used to remove the small particles, dust particles and particulate matter from the air. Then electrostatic precipitators, which use the phenomenon of electric charge to remove the air pollutants. So the charged particles are there. Coming to lecture 4, so gaseous pollutant control and using the mechanisms of adsorption and biofiltration. So how it is done. Lecture 5, so gaseous contaminant control using oxidation and condensation was discussed. So we'll have questions from almost everything. Two questions from every topic we will. So we'll see. So we'll start with the practice assignment. So coming to question 1, identify the air pollution control device which is not employed for the reduction of particulates from stationary sources. So the options are three-way catalytic converter, settling chambers, inertial separators, and cyclones. I'll drop the poll. Yes, we only have two people here. So, okay. Okay, so both are saying option A. So can you tell me where is catalytic converter used?
Mobile sources.
Yeah. Yeah. So I think we are clear on this. Mobile sources. Okay. We'll quickly see the answer for this. So yeah, settling chambers, if we take inertial separators as well as cyclone based converts. So all these are used for stationary sources. And if we take catalytic converter, this will be used for mobile sources which are in motion along with like other types of systems are there. air injection, evaporation control, and others. So these are used for moving sources. For stationary, we will have settling chambers, inertial separators, and all. So yeah, the correct answer is three-way catalytic converter. So option A is the correct answer here. Three-way catalytic converter. Moving to the next one, question number 2. Which of the following method is used to control emission of pollutants from crop residue burning, wind barriers, maintaining soil surface cover, spray tower, and happy seeder? Sponsors? Okay. And both people are saying option D. So yeah, crop residue burning is a pertinent issue, especially in if we take Punjab, Haryana, Western UP. So it is a problem there. So the stubble of the crops from the previous season or the previous harvest that exists, so they will just burn it. They say like it improves fertility. There is no scientific proof for that, like substantial scientific proof that it actually happens. Although some tribal communities use that, but so a better way is to remove it manually and just let the soil take its course. So happy seeder is a machine, we can say kind of. So that works very well for these cases. So what it will do is like it will first it can use very effectively remove the stubble of the from the previous harvest, and then it can be used to plant the seeds of whatever crop we want to grow. So that way we don't need to burn the stubble and which causes pollution. So yeah, so correct answer would be option D, happy seeder. Moving to question number 3 now. Identify the type of removal mechanism shown in the figure to remove particles from a gas stream. Brownian diffusion, inertial deposition, electrostatic attraction, and gravitational settling. And this is the figure. responses. Okay, when response is option A. Okay, yeah, correct. So let's see the answer now. Let's use some bright color. Maybe green should be good. Yeah. So here we can see the particles. Hope it is clear. So it is moving. So what we can infer from the motion, first it was going in this direction, then it went here, then it went here, then it is going here. So it is kind of a random motion which is associated with Brownian diffusion. So the pollutant gas will have these particulate molecules that will keep moving randomly. So this random motion will give them the tendency to get attached to the barrier. So this will be given some kind of a adsorbent, adsorbent or absorbent property. Both can be there. So using that, the particle will get stuck. So here, since the random motion is happening, the answer is Brownian diffusion. So yeah, that is correct. A similar diagram would be like the gas particle. Basically, let's use another color. So let's say the gas particle is here. It will go here. It will go here. Now we can see that the gas stream is turning, but the particle, due to its weight, the mass, the inertia will be there. So it won't move along with the gas stream, and it will go in the same direction. It will get attached to the barrier. So that is called as inertial impaction or deposition. So due to the inertia of the gas particle that is going, but here random motion is happening. So that is Brownian diffusion. So there is a subtle difference between the two, so that you should be aware of. So correct answer is Brownian diffusion. Option A is the right answer. Brownian diffusion. Moving to the next one, question number 4 now. So you have to choose the correct statement which pertains to settling chamber. Solids move along the chamber with Stokes velocity and settle with the velocity of the gas. Solids move along the chamber with velocity of the gas and settle with Stokes velocity. Solids move along the chamber with velocity of gas but do not settle with Stokes velocity, and they move along the chamber with Stokes but do not settle with velocity of gas. Just answer still not. Okay. So both of you are saying option B. That is right. Let's see the answer. So if you take the settling chamber, I'm just drawing a rough diagram here. It's not up to the specification or anything. So if you take the particle, so that is moving in. So what happens? It will come in with the gas stream. So let's say the settling chamber's length is L, and the gas is moving with time V. So what should happen is within the same time, when the gas passes through the settling chamber, this particle should be able to settle. So let's say this width or the thickness we can say is H, and this should be H by Vs. So the time taken for the gas to cross should be the time taken to settle. It should be less than that. So using this, we can get the Stokes velocity, which will be Vh by L. Or we can get it the other way around also. If you want to say like at what speed should the gas move, so that also we can get. Depending upon what we want to calculate, we can get it. So yeah, they will move in the chamber with the velocity of the gas. So yeah, this is there, but do not settle. No, this is not correct. So option B is the right one. So solids move along the chamber. They will move along with the gas, that is obvious, and they will settle with the Stokes velocity. I have told you the property. So the right answer is option B. They will move with the velocity of gas, settle with Stokes velocity. Moving to the next one, question number 5 now. Oxidizers can be used to destroy a wide variety of what type of in influent gases, effluent gas stream. Metallic compounds, organic compounds, inorganic compounds, and particulate matters. Responses. Okay. Any other response? Any other response? Otherwise, we'll move ahead. Okay, we'll see the answer. So yeah, oxidation we will do whenever there is a organic compound in the effluent, because oxidation will have the capacity to destroy these organic compounds that are present. So what are the types? So there will be high temp gas phase oxidizers, and then there will be catalytic oxidizers. So these are the primary categories. A basic example of oxidizer is also a flare-based system. So basically, the chimney itself will have a combustion system where the fire will burn, and whatever passes through that will get oxidized. So this technique of oxidizers, just a second. So this is mainly used when economic recovery is not important. So we don't want to recover what is in the, you can say, the effluent, so that is getting out. So in that case, we'll use oxidation. So I hope it is clear. So the correct answer for question 5 is organic compounds, which is option B. Moving to the next one, question number 6 now. The gaseous contaminant being absorbed must be at least slightly soluble in the scrubbing liquid, which is termed as absorbent, adsorbate, adsorbent, and absorbent. So one response for option B. Okay. So yeah, this question is from I think lecture 4 is there on absorption, adsorption. This is from there. So absorption, what do we do? So we'll convert from gaseous to liquid phase. And this will be done using the scrubbing liquid. So that gaseous contaminant which is there, so that must get absorbed into this. So what is this? This will be the absorbent. So that would be option A here. Since we are talking about absorption, option A is the right answer. Absorbent. So option A is the correct one. I think it is here. It is written as adsorbent. Let's correct it. So this will be absorbent. Maybe we can do like this. So absorbent is the correct answer. Moving to next one, question number 7. A gas ionization and particulate collection are combined in a single step in what device? Two-stage precipitator, single-stage precipitator, fabric filter, and bed scrubber. Yeah. Any other response? Right. So yeah, the correct answer here is single stage precipitator because we are talking about, yeah, they have been combined in a single step. So single stage precipitator is the right answer. So what happens is, so this is from the topic of precipitation. So what they will do is they will take, basically there will be two stages. So one will be the gas ionization. So here the gas will get ionized. Then we'll move to the next stage, which is particulate collection. Here they will collect the gas in the settling chamber. So two stages will be there and they will combine both of them in a single stage precipitator. So option B, single stage precipitator is correct, where both the gas ionization and settling will be combined into one step. Moving to question number 8 now. The adsorption process is classified as either physical or chemical. The type of force involved in physical adsorption is chemical interaction, van der Waals force, centrifugal force. There is no force involved in. Yeah. Two responses for option B. So yeah, option B is correct. Van der Waals force. So when we talk about adsorption, it can be either physical or it can be chemical. So this is also known as chemiosorption. So when we talk about physical, so here we will have the van der Waals force. This will be basically weak electrostatic forces, just enough to like get the particle attached to the surface. And here in chemiose option, from the name it is evident. So we'll have some kind of a chemical bond which will be developed between the gas molecule and the surface. So option B is the correct one, van der Waals force. So coming to question number 9, what is the ratio which is defined as the actual gas flow rate at maximum operating conditions divided by the total fabric area in the baghouse? Net cloth to air ratio, gross cloth to air ratio, net air to cloth ratio, and gross air to cloth ratio. Responses. So one response for option C. Anything else? So I would suggest you both to read the question again. Maybe one more try you can take. Any other responses? Okay, we have one response for D. We will see the answer. I think there is some issue, some clarity issue here. So this is from the topic of fabric filter. So basically we'll use a fabric or a cloth to remove the particulate matter. So there will be two things here. So one will be the A by C gross. So this will be, so we'll take the flow rate, we'll divide this by the, just a second. So we'll take this flow rate and we'll divide it by the total fabric area. So A total. Since we are taking the total fabric area, it will be the gross air to cloth ratio. So this is a parameter. So this is one thing. Second will be sometimes we'll use A by C net. So this will be, so the Q will remain the same. So this will be the maximum. This will also be the maximum. So Q will remain same, but area will take as net. So sometimes what can be the cases, so there may be multiple bags for removal of this pollutant. So maybe they are cleaning one or two bags, or some bags have been removed, they are under maintenance. Something like that has happened. So in that case, we can't take the total area. So we have to incorporate for the. So what they will do is they will give you the air total. They will say 90% of the bags are in function. So in it will be 0.9 times of air gross. So this way we can find the relation between them. So the correct answer here would be gross air to cloth ratio. Option D is the right answer. So gross air to cloth ratio. Moving to the next one, question number 10 now. Which of the following devices is not used to control gases from stationary sources? Spray tower, packed towers, venturi scrubbers, fabric filters. So that's, I think everyone has responded. Option D. There is some, like, there is not much merit in this question. Like, it's just some word plays there. So here instead of particulate, I had put gases. So to confuse, the thing is, so we'll have spray tower. So that will be used for stationary sources, gas removal. Pack tower is also used, venturi scrubber is also used, but fabric filter if we take, so this is not used because this is for particulate matter. This is not for gases because we want to remove the small particles through by passing them through the cloth. So the correct answer will be option D here, fabric filters. So fabric filters is the right answer. Moving to question number 11 now. Select the suitable device used to control industrial dust emissions, settling chamber, catalytic converter, positive crankcase ventilation valve, and all of the above. Yeah. So I think everyone is saying option A. Anyone else? Since we have three people here. Okay. No issues. We will see the answer. So we are talking about industrial dust emissions here. So we discussed this in one of the questions before also, that the catalytic converter is not used for industrial sources. It is used, but mostly it is used in automobile. So we can remove this. As far as this is concerned, positive crankcase ventilation valve. So big name, but nothing to worry about. This is basically known as a PCV valve in automotive industry. So basically it is used in cars for air dust control. So this also is not the case. If these two have been removed, all of the above can't be the answer. So we are finally left with settling chamber. So I just told you like why the others are incorrect. So to land at the correct answer. Obviously, you know settling chamber is used. So yeah. So option A is the right one. Settling chamber. So the right answer is option A, settling chamber. This is used for industrial dust emissions. Moving to question number 12 now. For the cost, from the cost and removal efficiency perspective, which of the following pollutant control devices is preferred for effective removal of the particulates above 40 micrometers in size? Inertial separators, cyclonic separators, settling chamber, and electrostatic precipitators, ESPs. So this is a carryover question from the previous one. So there we discussed what is the use case for settling chamber. So one response for option C. Anyone else? Yeah. Okay. So we have two responses for C now. So yeah, this is correct. Option C, settling chamber. So this is the use case. So basically we can use a settling chamber only when the size of the particle is higher than 40 micrometers. So there is a equation which was derived for the diameter of the particle that we can remove. So using that, we can find the diameter and should ideally be more than 40 micrometers. Then only a settling chamber works efficiently. So yeah, option C, settling chamber is the correct answer here for question number 12. Moving to the next one, question 13. What is the principal particle collection mechanism used in Venturi scrubbers, Brownian motion, electrostatic attraction, inertial impaction, and coagulation? Maybe draw up a poll also this time. One response for option A. Anyone else? We will see the answer. So Venturi scrubbers, they will use inertial compaction. So as we saw, we will have the barrier. So the gas stream will be moving around this. The gas stream will carry the particulate matter. So what happens is due to the inertia of the gas, these particulate matters. So instead of moving with the stream, they tend to, instead of like moving circularly along this, they will go in a straight line as they were moving in the original direction, and they will collide with the barrier and get adsorbed. So that is what is basically inertial compaction. In Brownian motion, we'll have the random motion, and due to that, it will get attached to the barrier. So yeah, that was the basic principle behind Venturi scrubber. So inertial impaction is the correct answer. Option number C, inertial impaction. Moving to the next question, question number 14. So this is from fabric filter. So you have to pick which statement is incorrect. So there will be three correct statements and one incorrect statement. Cleaning is required at regular intervals for efficient operation. Improper filter media increases the collection efficiency. The normal velocity of airflow through the bags is zero point 0.4 to 1 meters per minute. The air to cloth ratio is the main sizing parameter used for the fabric filter. We have one response for B. Okay. Any other response? Okay. So we have three responses for B. Fine. So yeah, not much to, it's all kind of obvious. So cleaning will be needed at regular intervals for efficient operation because the filters will get clogged with the particulate matter. We have to clean it to remove it. We also discussed this topic, air to cloth ratio. So it can be either gross or it can be net. It is used as the main sizing parameter. So this is also fine. Normal velocity is 0.4 to 1. But if we see here, it is saying improper filter media will increase the collection efficiency. So anything improper cannot yield into something good. So this is wrong. So the correct answer here would be option B. So highlight this because everywhere it is green color. Improper filter media increases the collection efficiency. So option B is the correct answer for question number 14. Moving to the next one, question 15 now. The quantity of recirculation liquid used in the absorber divided by the outlet gas flow rate is called gas to liquid ratio, absorption efficiency, liquid to gas ratio, adsorption efficiency. One response for option C. Anything else? Any other responses? Okay, we'll see the answer. So two responses for C. So we are talking about quantity of the recirculation liquid and it is divided by the gas flow rate. So we are taking some quantity of a liquid dividing it by the gas. So what it will be? It will be liquid to gas ratio. It has nothing to do with adsorption efficiency. It is also not linked with the absorption efficiency. So it can either be gas to liquid or liquid to gas. But since we are saying liquid divided by gas, so it will be option C, liquid to gas ratio. So option C, liquid to gas ratio is the correct answer for question 15. Moving to next one, question number 16 now. Biofiltration can be classified as a special type of absorption system using what type of process to control the gaseous contaminant? Reversible, irreversible, equilibrium, and it can be both reversible as well as irreversible. Two responses for option B. Any other response? Yeah, we will see the answer. So biofiltration, what do we do? We'll use microbes here. So these microbes will be present in a aqueous environment and they will act upon the organic pollutants. So these pollutants will be first absorbed into this aqueous medium where the microbes will act, and this will lead to the emission of carbon dioxide, water, other harmless substances. So this process is irreversible. You cannot reverse it. The primary thing is environmental biofiltration we need to remember is we are using microbes here and it will finally lead to CO2H2O. The process will be irreversible. So the correct answer will be irreversible, which is option B here. So for question 16, the right answer is irreversible. Moving to the next one, question number 17, that is, which of the following primary forces is responsible for the particle collection in cyclone collectors? Electrostatic, Brownian diffusion, centrifugal, and gravitational. So we have one response for A, one response for C. Any other responses? Okay, we'll see the answer. So first is electrostatic. So this we used in electrostatic precipitator. So electric charge will be used. It's the basic principle. Gravitational we have seen in many of the cases by now. So it is used in settling chambers. So under the force of gravity will force the particle to settle in the downward direction. Brownian diffusion we have used in fabric filters. We are left with centrifugal. So basically what we do is we'll keep moving the particle in a circular fashion, and centrifugal force will be generated, due to which the particle will go in the outward direction and get removed. So that is the principle behind cyclonic collectors. So the right answer here would be option C, centrifugal. So that is question number 17. So right answer is option C, centrifugal. So this is used for cyclone based collectors. So finally coming to the last question, I think, for today's session, question number 18. Which device is fitted in vehicles to control air pollution from the tailpipe emissions? Electrostatic precipitator, catalytic converter, bag filter, cyclone separator. So what device we use for air pollution in vehicles? How to control that? Okay. Two responses for option B. Anyone else? Saying option B. That is right. So yeah, catalytic converters are used in vehicles to remove the emissions. And this has been particularly implemented when BS4 was upgraded to BS6. So before, I think catalytic converters were not there. Only few vehicles were giving in the top end models, but now it is essential for all of them to provide the catalytic converter to remove the tailpipe emissions. So this is a standard now in Bharat State 6. So this is where EVs come in. So they say that electric vehicles will not have tailpipe emissions because they are not emitting anything. But there will be other types of emissions, like when the EVs move, the tire will release some small dust particles and tire fragments will be into the atmosphere. So tailpipe emissions are not there in EV, but other types of emissions will exist. So EV is emission free is a wrong statement. Only tailpipe emission is not there. So yeah, that is the last question. So option B, catalytic converter is the right answer. So with this, we come to the end of today's session. So for the next week, I would suggest all of you to carefully go through all the equations and formulas that have been discussed in week 9, and if there are any in week 10 also. So you should go through that, and please keep a paper, calculator, and pen handy for the next week because we will be doing numerical problems. Not very sure if it is allowed or not. Maybe you can ask in the discussion forum. As far as I know, there will be a online virtual calculator that you can use. I'm not sure if physical calculator they allow. Can check it out. So next week, basically, we'll be doing most of it will be the problems and some theory questions will be there. Mostly from this week only. Whatever equations, formulas have been discussed, we'll use them to solve the questions. I think that will be useful. We have not done many numericals till now, but next week we'll do it. Question number 11. Okay, let's see what is that. 11 was basically what is the suitable device for controlling dust emissions from industrial sources. Catalytic converter is used for mainly mobile sources, automobiles, cars, bikes. Positive crankcase ventilation. This is also used in automobiles only, PCB valve. So if these two are incorrect, all of the above can't be the answer. So we are finally left with settling chamber only. So that is used. Industrial, they have given the keyword to distinguish between the options because the other options are for vehicular sources. Using the force of gravity, we'll return the particle here. So same concept of settling chamber where air pollutant is settled down. It is used in water supply also. So there they will do use the sedimentation tank to remove large size particles. The same concept is used of Stokes velocity here also there. So there we clean water, here we are trying to clean the air. Any other doubts? We can do that, we have time. Let's see quickly. So this was the first question. So it was asked which of the following pollution control device is not employed for reduction of particles from stationary sources. So settling chambers, inertial separators, cyclones, all these we use for stationary sources, but catalytic converters are primarily used in mobile sources, which are air injection and along with air injection and evaporation control techniques. So mobile sources are basically automobiles. So that is not used for stationary sources. That is option A. Question 2 was which of the following methods is used to control the emission of pollutants from crop residue burning? So crop residue is burned like to improve the fertility of the fields, to remove the small stubble that is left from the previous harvest. So instead of trying to burn it, happy seeder is a type of machine that is used nowadays. So that will remove the previous stubble and it can plant the seeds also. So it can do it efficiently without causing air pollution. So this is option D here. Question D was about which of the following. So it's a removal mechanism, the gas stream. So this black figure I have drawn over it. So I don't know if how much it is visible. So the black particle keeps moving in a random motion. So whenever there is a random motion, that will be going in with Brownian diffusion. And I also discussed inertial impaction. So here the particle will move along with the gas stream as much as possible. But once the gas stream curves around the barrier, the particle won't be able to do that because of its mass inertia. So it will go and collide with the barrier and get absorbed. So that is inertial deposition. Gravitational settling, we will use in settling chambers. So we'll use the force of gravity. And electrostatic attraction, we will use electric field. Question 4 was so about settling chamber. So here we have asked so what velocity they move in the chamber. So they will move in the chamber with the velocity of the gas. And when they want to settle, they will settle with the Stokes velocity using the force of gravity. So the time they take to cross the tank, so that will be the length of the tank divided by the speed of the gas will be equal to the height divided by the settling speed, which is we get from Stokes law. So using this, we can get the Stokes velocity. So question 5 was about oxidizers. So in what use case they are used? So oxidizers we will mainly use for organic compounds because they can destroy them using so we have high temperature gas phase oxidizers, we have catalytic oxidizers. So mainly we will use them when economic recovery of the particulates and gas is not important. Question 6 was so basically we are being asked what is the scrubbing liquid that is used in the absorption process. So that is called as absorbent. So not much question, not much in this. So option A is the correct answer. So yeah. What is the type of device in which we combine gas ionization and particulate collection together? So gas ionization will ionize the gas to charge the pollutant molecules emission, and next stage will collect them in a separate chamber. So these are two different stages, but when we bring them together in one single step, so that will be called as a single stage precipitator. Moving to question number 8. So what type of force we use for physical adsorption? So we can have two types of adsorption. It can be physical or it can be chemical. So when it is physical, it will be based on van der Waals forces, which are weak electrostatic forces. Chemical will be based on chemical bonds. So we are being asked about physical, so that will be van der Waals forces. Question 9 was about what is the actual gas flow rate at maximum operating conditions divided by the total fabric area in the baghouse. So we are taking gas flow rate by total fabric area. So it is basically air by cloth ratio. So here, since we are taking total area, so it will be gross air to cloth. If we take the net area, which may be due to cleaning or maintenance, we'll take the net air to cloth ratio. Question 10 was about which of the following is not used to mine from stationary sources. Yeah. So we are talking about gases here, not particulate matter. So spray towers, pack towers, venturi scrubbers, all these are used for gases, but fabric filters are used for particulate matter. They are not used for gases. So I think after this, everyone was there. So, yeah. I hope it is clear. Any other doubts? Yeah. Since we'll wait for maybe 1 more minute. If anyone has any doubt, you can drop it. So PPT will be uploaded in the Excel sheet. Okay, since there are no more doubts, we'll close the session. Yeah, thank you for attending. Have a great weekend. Happy Holi to everyone. Thank you.